you very much. It's been about 7 to 8 years since I had my first ever meeting with Mike. We at NVIDIA, of course, have a very, very close relationship with Quanta over the years, but Mike and I both started building the enterprise business roughly the same time. So we've seen our businesses grow, from a small base up to a very, very large business, thanks to the help that we're getting from you, our customers. So today I'm going to share with you more details about how the computing industry is changing and our position in that changed industry, and how we and QCT are working together to help you, our customers, accelerate your workloads for the new computing industry. Why do I say the computing industry has changed? Two main reasons. Firstly, the end of Moore's law. You can't just get a free ride based on a process improvement so that you can pack more transistors into the same size of die and using with the same amount of power, get more performance. That free ride has kind of disappeared over time. More innovation is required in order to reach the kind of performance that the Uber team talked about in their presentation. Secondly, the start of neural networks and deep learning. And today we have, what is virtually a Cambrian explosion of the number of neural networks doing different types of workloads, ranging from image and video analytics all the way through to natural language processing in multiple languages to generate a conversational artificial intelligence. So the world of computing has changed. And those of you who are in the hyperscale business here in the audience know the amount of data that you're looking at has absolutely exploded. The amount of research papers in this new domain of artificial intelligence has grown astronomically. I was even in a traditional industry like the oil and gas seismic processing industry, there were 65 papers on the use of artificial intelligence and machine learning to explore and discover oil under the ocean. If you go to any medical imaging conference or computer vision and pattern recognition, it's right in front of you. The computing industry has changed. Venture capital funding in the artificial intelligence space has grown astronomically. We now have more than $9 billion of funding. Some people, of course, are talking about, well, maybe there's a overvaluation. We don't care about that. What we care most about is the type of applications these startup disruptors are creating is changing the computer industry. And last but not least, the number of models that people are using to do image, video, voice, sound, sensors, and so on. The computing requirements of those models has grown astronomically. The chart on your right is a log chart. So you can see, ResNet is at, I think, 0.1, and Google machine learning and neural machine translation is, I think, over 100 on that graph. So just think about that's a log scale. So computing requirements based on data have exploded, and therefore the world of computing has changed. And so new form of computing demands a new computing company. And so we at NVIDIA are a specialist computing company. We don't focus on all workloads. We focus on a narrow vertical set of workloads. They're all meaningful, they're all relevant, they're all big markets, but we're very, very focused on these specific workloads. So you'll see graphics as an intensely computationally intensive workload, whether it's gaming, interactive, immersive gaming, it's design and content creation, the amazing things that we can now do with our 3D Omniverse collaborative environment, and then of course finally absolutely crystal clear, realistic, photorealistic rendering done in real time. Graphics is our #1 historical specialist computing workload. Secondly, high-performance computing, all of the laws of physics and chemistry and now biology, where we take an equation and simulate that equation using huge amounts of computing to generate an answer and compare that answer with the actual physical reality to make sure we're doing the correct numerical simulation of those physics, chemistry, and biology workloads, and all the derivative sciences like materials, and genomics, and so on. High performance computing. Today, we are in the number one computing, high performance computer in almost all of the nations in the world where we are allowed to operate. And then thirdly, the data analytics, where we start with huge amounts of data, today called artificial intelligence with neural networks and deep learning, and we back calculate using a neural network to calculate what the reality is. And we have now reached superhuman capabilities for image, video, voice, text-to-speech, all domains. Even playing a game is now superhuman, where the machine can, with a little bit of help, with good computing, actually be better than human beings. So that's the domains that we focus on: graphics, HPC, and AI. And we do this with what we call a GPU computing platform. Not a chip, not just hardware, a platform, hardware and software. Right at the top, I'm showing you our NGC containers. NGC is our cloud-native containers. Today we have over 60 containers for HPC, visualization, and AI, all optimized, all performant, running on every cloud and on every one of our OEM partner servers as a set of containers. And those containers embody our application frameworks. Drive is for autonomous vehicles, self-driving cars, vans, robots, and so on. Metropolis is for intelligent video analytics for smart city, safe city, retailing, and factories. Clara is our software for genomics and medical imaging right now. Isaac is our robotics simulator to train all the robots out there. And then Omniverse, as I already said, is our 3D collaborative environment for visual content creation and design. And that runs on a set of middleware. CUDA-X is what we do for high-performance computing and machine learning. vGPU is our hypervisor that plugs into all of the VMware and Citrix and cloud people's hypervisors, KVM hypervisors. Everything is in containers with an open source Docker, and we do our scale out using Kubernetes is our preferred way to do that. And then, of course, that sits on the computing systems, the hardware, if you will. So that computing platform is one common architecture, hardware and software, from the device, a little robot, the edge computer, the on-premise data center, or the hyperscale public cloud computing data centers. One common hardware and software architecture. And that is something that is extremely compelling to the thousands and hundreds of thousands of developers out there, because it's easy to develop and easy to deploy. The same software can be deployed across the entire spectrum of device, through edge computing, through on-prem and on-cloud data center computing. And the hardware way of looking at this is we can start to see with the AGX platform that we have, any maker fair you go to, any FIRST Robotics event, a lot of the schools, a lot of the universities, tons and tons of different types of robots for medical, for delivery, for autonomous vehicles. We even have huge robots which excavate, from Komatsu, excavate into mines, and health and safety matters a lot. And now we're in edge computing. Those of you in the telco business, please do come and see us at Mobile World Congress Americas. Jensen Huang is going to be doing a keynote on the Monday at MWC Americas in a couple of weeks' time. We have a lot of edge computing devices now, thanks to our partners in factories, in hospitals, in logistics areas, in cell phone towers, in camera towers, and the like. And of course, as previous speakers pointed out, 5G will result in an explosion of these edge computing devices. All of these devices have featured either normal computing or what we call GPU accelerated computing. And the way GPU accelerated computing works is the more you accelerate the application, the fewer nodes you need, and as a result, your TCO goes down and you save money. And we have shown this time and again in our hyperscale and high-performance computing data centers, and the same principles will apply for edge computing. So many of you here are hyperscale and you care about machine learning performance. Google and a number of people in the community sat down together and started to define the benchmarks for machine learning. So we have MLPerf, and our new DGX systems are right at the top, at the leading edge of the performance league table for machine learning performance. And across the range, we are breaking all the records. We've done it once, we've done it twice. It's a really good, fun battle out there. But notice some of the people are absent from the battle because to do these benchmarks requires you to operate at scale, which NVIDIA invested in. We run the SuperPod on our own computer. It's number 22 on the top 500. And we're taking the goodness of all of that, and taking the innovation of all of that, and packaging it up into containers that allow you to accelerate your training, accelerate your inferencing, and accelerate your machine learning. So these are the three areas that I would like each of you to be considering when you are thinking about deep learning training, deep learning inferencing, and machine learning. So let me take you through it. Auto mix precision is the way in which we accelerate training for TensorFlow, for PyTorch, for MXNet, for PaddlePaddle, and so on. And it automatically takes your model and exploits the tensor cores in our Volta and beyond GPUs so that you get significantly better performance for your model training. So if you see the chart in front of you, you'll see this is ResNet 50. A CPU is the blue bar, and out of the box, without using auto mix precision, you'll get at least a 2x performance improvement over the bestest CPU. And then when you add the auto mix precision, it takes advantage of the huge amount of cores, FP16 cores that we have in the GPU, and gives you something like 5 to 6 times better performance for model training. Likewise, we have a piece of magical software called TensorRT and the TensorRT inference server, and that speeds up your inferencing for image, video, and other inferencing workloads. And you can see, a CPU with a standard TensorFlow out of the box on the CPU is the blue bar, 11 times better on inferencing without any additional NVIDIA software. And then when you add the TensorRT, which is a optimizing compiler which tunes the performance so that you get the bestest performance at the edge for your inferencing, you'll get almost 50 times better performance. So I urge you, if you are using GPUs, either on-prem or in the cloud, to use the NGC containers, which are fully optimized for deep learning training, for inferencing, and now for machine learning. On the right is our Rapids open source machine learning framework. We're pretty good right now with XGBoost. We're actually exceptionally good with XGBoost. We are pretty good with K-means and random forests as well. And we are continuously adding more and more functionality for traditional machine learning to be accelerated. So you can see CPU is at 1.0. If you use our XGBoost with a big, huge DGX2, you'll get about 11 times better performance for the same workload end to end, which includes the ingestion and the final result that you get from the system. So there's many, many ways of accelerating your software to do this new form of computing. So how do we work with QCT? Basically, we work with QCT just like we work with all of our OEM partners. Of course, we work with Quanta as an ODM for certain types of customers. But here we are working with end customers like yourselves with the QCT brand to take the goodness of accelerated computing in a very wide range of servers to bring it to you. That's the first thing. The second thing is rack scale solutions. We think QCT is really good when you want to build out a data center with multiple racks. And the innovation that their engineering team brings in terms of cooling and PUE efficiency, as shown in the Taiwan supercomputer and in other workloads, is outstanding. Our engineers love working with JJ and his engineers to really bring you the best rack level solutions on top of the node level solutions that they already developed. And then what we're doing now, which is really kind of innovative, is working on industry vertical workloads for healthcare, for automotive, and for data analytics with AI, industry-specific workloads, and optimizing them on these rack-level solutions. So let me end with two really interesting examples of how we are working together. The first is NetApp, a really good OEM partner of ours, and they do hyper-converged infrastructure in addition to storage and all the goodness they do there. And we have taken our VDI, accelerated graphics in the data center technology, working with Quanta to put that into one of their hyper-converged infrastructure appliances. And so the beauty of this solution is it optimizes performance for three workloads. Number one, the media and entertainment workload, the content creator workload, where the artists can create movies and adverts and other digital content in a photorealistic way with a huge amount of performance improvement. Literally, you can get out, architectural drawings in minutes rather than days using GPU-accelerated ray tracing. Secondly, we have great performance for all of the computer-aided design, computer-aided engineering, electronic design automation, all of the traditional technical computing workstation workloads now run in an accelerated data center on this NetApp appliance. And then lastly, for medical imaging, which combines some deep learning aspects into medical imaging and image reconstruction for 3 and 4D modalities, we have a 6 times performance improvement over what was possible without a GPU in this appliance. So that's the NetApp story. We're working very, very closely with QCT. And then, of course, we're all, especially our company, very, very pleased that Taiwan now has a computer in the top 20 in the world. We hope this computer will be expanded. It is doing groundbreaking research work with all the hospitals. We have a special project working with the Quanta community to really improve the quality of diagnosis and detection and prevention and the treatments for the communities in Taiwan, working with the healthcare communities. We also obviously want to improve Taiwan's capability as a nation for robotics, smart manufacturing, and the Taiwan 2 supercomputer is a core asset for this endeavor. And it's really great that the entire country can benefit from accelerated GPU computing, this new form of computing, which I've hopefully given you an idea of what it's about. So if you think this new computing is for you, if you are in the hyperscale business, if data analytics and AI and deep learning matter to you, if you're in the telecom business and want to do both analytics and set up a cloud, I think that these are the 4 things that you could do to get started. Number one, think about modern data centers, which have a different power envelope, a different density, a different type of scale-out environment. QCT has a phenomenal range of these servers. Number 2, use the NVIDIA GPU Cloud. It's an absolutely free resource. Every single container, every model training script, every trained model, and all of the vertical workloads are all free to the community. And of course, they work best on GPU computing. Thirdly, we run regular training exercises and labs and hands-on at every conference we're at. At Mobile World Congress, there'll be hands-on labs on deep learning and machine learning and computer vision and so on. And our technical experts will help you hone your technical skills for this new form of computing. And the same classes are available for free on the web. We just spin up an AWS or a GCP instance for you, and you have it for the duration of your class. And then lastly, come and meet the experts at our GTC conference. It's an awesome gathering of the world's best experts in GPU computing across all the different domains. Please come and join us there. So I hope I've given you a flavor for GPU computing, one architecture for all these workloads, AI, high-performance computing, and visualizing from device through to edge, through to data center, on-premise, and on cloud. And we're delighted to be working with QCT to help you on your journey towards accelerated computing. Thank you very much.